Hello, everybody. Section 6.3 and 6.4 are the two sections that will be covered today, Tuesday, March 31st. Hopefully, everybody's healthy and staying safe. Last week, in section 6.2, we showed you how to factor the easy types of trinomials, those being trinomials where the leading coefficient was 1. Well, today we're going to look at how to factor the difficult types of trinomials, those that no longer have a leading coefficient equal to 1. Factoring these types of trinomials is a little bit more involved than factoring the types that we looked at last week. There are two main schools of thought or methods for factoring these types of trinomials. One method is called the trial and error or the guess and check method, and the other technique is called the grouping method. Through the years, I've discovered that the grouping method is a little bit more systematic and is not as um, guess and check as the trial and error method is. Now, the grouping method does have steps, but once you get the steps down, you fly through these and you will become very efficient with a lot of practice. So I'm going to show the grouping method for factoring these difficult types of trinomials. Now, you may recall that the grouping method was used for factoring four-term polynomials a ways back. And you're probably wondering, how can we use the grouping method to factor a trinomial, a three-term polynomial? I thought the grouping method was, reserved for four-term polynomials. Well, you'll see, ladies and gentlemen, how we'll be able to rewrite a trinomial like this as an equivalent four-term polynomial, which then can be factored via the grouping technique. Okay, so let's just dive right in. And through showing you several examples, you'll come to understand this grouping technique for factoring these difficult types of trinomials. Okay, so the instructions, like they have been for the entire chapter, is the word factor. Okay. All right, let's start off with this one, 2x squared plus 5x plus 3. Notice there is nothing we can factor out of all three terms of this trinomial, except 1 or negative 1. And so in order to factor this trinomial, we need to factor it as a trinomial. Upon further inspection, this is a trinomial where the leading coefficient is not equal to 1, like last week. And so in order to factor this type of trinomial, this so-called difficult type of trinomial, we're going to have to employ the grouping method. Now this is how the grouping method begins. What we do is we start by taking the product of the leading coefficient and the constant term. So we take 2 and multiply it by 3, and I'm going to do that off to the side of the paper over here. We'll call this our product. And then, so our product is positive 6. And our sum is going to be, just like last week with the easy types of trinomials, it's going to be the middle coefficient, which is positive 5 in this case. All right, so here's our goal. Just like last week when trying to factor the easy types of trinomials, the same thing holds true for these difficult types of trinomials with this product sum table here. We're going to try to find two factors of positive 6 that add up to positive 5. The only factors of positive 6 are 1 and 6, 2 and 3, negative 1 and negative 6, and negative 2 and negative 3. Now, the only factors in this list that sum up to 5 is not going to be 1 and 6. It's going to be 2 and 3. Those are the only ones that work. Notice none of these negative factors will add up to positive 5. These don't work, and these don't work. So positive 2 and positive 3 are the only factors of positive 6 that sum up to a middle coefficient of 5. Now this is where things differ between last week versus this week. Between the easy types of trinomials and the difficult ones, now where the leading coefficient is not 1. What we do is we rewrite this trinomial now as an equivalent four-term polynomial. The middle term 5x gets split up and rewritten as the sum of our decided upon factors over here. So 5x is rewritten as 2x plus 3x. Or you could have these switched around. You could have plus 3x plus 2x. Doesn't matter what order in which you list these. You'll get the same factorization in the end, plus the 3. So what we've effectively done, we have rewritten this trinomial as an equivalent 4-term polynomial, where the middle term 5x is represented now as the sum of 2x and 3x, 2 and 3 being the decided upon factors over here. Now that we have a 4-term polynomial, to factor it, we're going to employ the grouping method. So we group together our first and last 2 terms by placing them inside parentheses. Notice there is no sign adjustment necessary in the last term since we have a positive sign that precedes the 3rd term of this 4-term polynomial. All we do is throw parentheses around the last 2 terms. Now out of the first 2 terms, what can we factor out? The greatest common factor of 2x squared and 2x, after a little thought, is 2x. So we can factor 2x out of the first 2 terms. And when we do so, we're going to leave behind x plus 1. Plus, what can we factor out of the last 2 terms, 3x and 3? Well, the greatest common factor of 3x and 3 is positive 3. And when we factor the positive 3 out, we leave behind x plus 1. Now, ladies and gentlemen, notice that we have a common binomial factor of x plus 1 that is shared by both these terms here, separated by addition. Being the case, we can factor the x plus 1 out of both these terms. And when we factor it out, like we did last week with a 4-term polynomial, we only write it down once on the next line. Times, what do we leave behind? Well, when you factor x plus 1 out of the first term, you're going to leave behind 2x. Plus, when you factor x plus 1 out of the second term, you leave behind 3. And we're done. This is the correct factorization of this difficult trinomial 2x squared plus 5x plus 3. And check your answer if you want to. You could always FOIL this back out, multiply it all back out, and convince yourself that you would get back this trinomial. This entire procedure, ladies and gentlemen, is called the grouping method, and it looks like it's a very tedious, involved method, but rest assured that with practice, enough practice, you're going to become very, very efficient at flying through these steps seamlessly. It takes practice, as anything does. All right, so let's try another one. Okay. Let's try to factor this one. Hold on a second. I got a little problem with the focus. Okay. All right, we'll try to factor this one here. 3x squared minus 2x minus 5. Again, there's nothing we can factor out of all 3 terms, and so therefore we're going to have to try to factor it as a difficult type of trinomial, one where the leading coefficient is not positive 1. To do so, we begin by multiplying the leading coefficient and the constant term. So 3 gets multiplied by negative 5. And that gives us a product of negative 15. So over here to the right side, off to the side of my paper, I'm going to form a little table called the product sum table. The sum we're shooting for has to be negative 2, which is the middle coefficient. Now we're going to try to list factors of negative 15 in hopes of identifying a couple that add up or sum up to negative 2. Negative 1 and 15 are factors of negative 15. Positive 1 and negative 15 are factors of negative 15. 2 don't divide into 15 evenly, but 3 does. Negative 3 and 5, or 3 and negative 5 are factors of negative 15. And those are all of the factors of a negative 15. Now the only 2 in this list that sum up to negative 2 are going to be which ones? Well, it's not going to be negative 1 and 15. These add up to 14. It's not going to be 1 and negative 15 because these sum up to negative 14. Is it negative 3 and 5? No, these add up to positive 2. Might it be 3 and negative 5? And there we go. Those are the ones that work. So the only factors of negative 15 that sum up to negative 2, the middle coefficient, are going to be 3 and negative 5. Now that we've identified the proper factors that add up to our middle coefficient, I'm going to rewrite this trinomial now as an equivalent 4-term polynomial. So this is going to be rewritten as 3x squared. Negative 2x is going to be rewritten as the sum of our decided upon factors over here. namely plus 3x minus 5x, plus 3 minus 5, the constant term. So we've effectively rewritten our trinomial now as an equivalent four-term polynomial, of which can be factored via the grouping method. So now we group together our first and last two terms. Notice we have a minus sign that precedes our third term, and being the case, we're going to have to be very careful how we group these last two terms together. I'm just going to bring the minus sign down, throw parentheses around our last two terms now, keeping in mind that we must change the sign of our last term. Now, out of the first two terms, what can we factor out? Well, we can factor out a 3 and an x. And when we factor 3x out of the first two terms, what do we leave behind? Well, we leave behind x plus 1. Bring the minus sign down. What can we factor out of 5x and 5? Well, the greatest common factor of 5x and 5 is 5 times. And when we factor 5 out of 5x plus 5, we leave behind x plus 1. Now, ladies and gentlemen, we have a common binomial factor of x plus 1 that can be factored out of both these terms. And when we factor it out, on the next line of our paper, we'll put an equal sign, and we only write the x plus 1 down once, times, and inside another set of parentheses, we write down what we leave behind. When you factor the x plus 1 out of the first term, you leave behind 3x. When you factor it out of the second term, you leave behind the minus 5. And we are done. This is the correct factorization of this trinomial above here. Again, this entire procedure is called the grouping method for factoring difficult types of trinomials, ones where the leading coefficient is not 1. Okay, let's try another one here. We're going to try to factor this trinomial here. Again, notice there's nothing we can factor out of all three terms except 1 or negative 1. So we're going to factor it as a difficult type of trinomial using the grouping method. To begin, we take the product of the leading coefficient and the constant terms. So we multiply 6 times 6. That gives us a product of 36. And our sum must be the middle coefficient of negative 13. I'm going to start listing factors of positive 36, and since the two factors have to sum up to a negative number, there's no sense in listing the positive factors of 36. That is a waste of time. Let's only list the negative factors of 36. Negative 1 and negative 36. Negative 2 and negative 18. Negative 3 and negative 12. Negative 4 and negative 9. And negative 6 and negative 6. Now we're searching in this list for a couple of factors that sum up to negative 13. It's certainly not negative 1 and negative 36, as these add up to negative 37. It's not negative 2 and negative 18, as these add up to negative 20. Is it negative 3 and negative 12? Well, these sum up to negative 15. We're getting closer to negative 13, but the search must continue. Is it negative 4 and negative 9? Here it is. Negative 4 and negative 9 add up to what we need, namely negative 13 for a middle coefficient. Don't bother with a negative 6 and negative 6. Therefore, the only factors of a positive 36 that sum up to negative 13 are going to be negative 4 and negative 9. We come back to our main problem, and now we're going to rewrite this trinomial as an equivalent four-term polynomial, 6t squared, where the middle term gets split up and rewritten as the sum of our two decided upon factors over here, negative 4 and negative 9. So negative 13t is rewritten as negative 4t minus 9t. And bring a constant plus 6 down. Now that we've effectively rewritten our trinomial as an equivalent four-term polynomial, we're going to use grouping to take us the rest of the way in actually factoring this four-term polynomial. So what we do is we throw parentheses around our first two terms. Notice we have a minus sign in front of our third term. Being the case, I'm going to leave it outside the parentheses when I group together my last two terms. keeping in mind, of course, that we must change the sign of the last term. So plus 6 must be reported as a minus 6 inside the last set of parentheses. Now, out of the first two terms, we can factor out a 2 and a t. And when we factor 2t, the greatest common factor, out of these first two terms, we leave behind 3t minus 2. Bring the minus sign down. What can we factor out of 9t and 6? After some thought, the greatest common factor of 9t and 6 is 3. And when we factor 3 out, we're going to leave behind 3t minus 2. Now notice, ladies and gentlemen, we leave behind a common binomial factor shared by both these terms, which can be factored out of both the terms. So we factor it out on the next line, put an equal sign and write it down only once, times, and what do we leave behind in doing so? Well, when we factor 3t minus 2 out of the first term, we leave behind 2t. And when we factor 3t minus 2 out of the second term, we leave behind minus 3. And we're done. This is your correct factorization of the difficult trinomial we initially started with back up here. This is called the grouping method. Now, sometimes when these numbers get a little larger, sometimes your search for the correct factors does take a little bit more time. But normally I'm going to keep the numbers kind of small, this being elementary algebra, in which case we're not really supposed to be using a calculator. When you get an intermediate algebra, well, let's see, college algebra, some of the numbers start to get a little larger, but then you're able to use a calculator to alleviate the tedium of the search for the correct factors. Okay, to factor this difficult trinomial, notice there's nothing we can factor out of all three terms. Being the case, we kick off the grouping method by taking the product of the leading coefficient and the constant term. So we're going to multiply 20 times negative 5. So 20 multiplied by negative 5 yields a negative 100. That's your product. And then your sum that we need has to be the middle coefficient, which is negative 48. So the search is on now to find two factors of negative 100 that add up to negative 48. I would recommend climbing the ladder, starting with 1, trying 2, trying 3, trying 4, 5, 6, and climbing the ladder. That way you won't miss any. So negative 1 and 100, or positive 1 and negative 100 are factors of negative 100. Negative 2 and 50, or positive 2 and negative 50. 3 don't divide into 100 evenly, 4 does. Negative 4 and 25, or 4 and negative 25. 5 divides into 100 20 times, so negative 5 and 20, or positive 5 and negative 20 are factors of negative 100. 6 don't divide into 100 evenly, 7 don't, 8 don't, 9 doesn't, 10 does, so negative 10 times 10. And there is the comprehensive list of all factors of negative 100. Now in this list we're searching for a couple of factors that sum up to negative 48, and it's certainly not going to be negative 1 and 100 or 1 and negative 100. It's going to be one of these right here, and the ones that actually work are going to be 2 and negative 50, since 2 plus a negative 50 give us the proper sum of negative 48. So 2 and negative 50 are the only factors of negative 100 that sum up to negative 48. That being the case, we come back to our main problem, and now we're going to rewrite this trinomial as an equivalent 4-term polynomial, namely 20m squared. The middle term is going to be split up into the sum of our decided upon factors back over here. So 20m squared plus 2m plus 2m minus 50m. Don't forget to bring down the minus 5. So there's your equivalent 4-term polynomial. There's your equivalent four-term polynomial for this trinomial here. And now to factor this four-term polynomial, we're going to use the grouping method to take us the rest of the way. So we place parentheses around our first two terms. Got a minus sign before the third term, just bring it down and leave it outside the parentheses. And therefore, to group our last two terms together, we're going to have to say 50m plus 5. Remember, when you got a minus sign that precedes your third term of a four-term polynomial, when you group your last two terms, you must change the sign of your last term to avoid a sign mistake. It's only when you got a minus before your third term. If you have a plus sign before your third term, you don't change the sign of your last term. All right, what can we factor out of the first two terms? Out of the first two terms, we can factor a 2 and an m out. So 2m is the greatest common factor of both these terms. And when you factor 2m out of 20m squared, you leave behind 10m plus. When you factor 2m out of 2m, you leave behind 1. What can we factor out of 50m and 5? After some thought, 5 is the greatest common divisor or factor of 50m and 5. So we can factor a 5 out. And when we do so, times, we leave behind 10m plus 1. Notice we have a common binomial factor of 10m plus 1 that cannot be factored out of both these terms. Next line, put an equal sign. Just break the 10m plus 1 down once, times. And what do you leave behind after you factor the 10m plus 1 out? Well, when you factor out the first term, you leave behind 2m. When you factor out the second term, you leave behind minus 5. And there you go, ladies and gentlemen. That is the correct factorization of this trinomial 20m squared minus 48m minus 5. This is called the grouping technique. Like I said, with practice, you will become more comfortable with all these steps of the grouping technique, and with a lot of practice, you're going to fly right through all these steps seamlessly, and these really won't be an issue whatsoever. Well, that concludes section 6.3. The key to success, ladies and gentlemen, is first of all, try not to fall behind. I know times are crazy right now, and we got a lot going on in our personal lives. And the problem with working at home is the fact that there's a million other things that we'd rather be doing. There's a lot of distractions at home. But we have to try to, resist the urge to stray away from our studies. Just try to set aside some quality time for your algebra class and your other college classes to try to make it through this semester. I do wish you all the greatest of luck, and stay healthy. All right, I will now begin to compose the lecture for section 6.4.